Hello, everyone. Welcome to our presentation. Our group name is JobLink Analytics, an AI-powered career intelligence platform. I'm the group leader, Rowan, and our group member are Ashley, Augusta, Bruce, and George. And for our business needs, our JobLink Analytics platform can deliver two core use cases that transform raw linking data and in-day data to actionable career intelligence. Firstly is the skills gap analysis, which can identify the missing competencies by comparing users' profiles against the market demands. And then is the resume-based job matching. It can automatically match candidates to relevant positions while generating personalized cover letters or advices. And together, this can create a comprehensive career intelligence platform that guides the professionals from assessment to action. And this is our architecture diagram. Firstly, we built two VPCs. The first one on the left is where we put our Lambda functions and our S3 buckets. And the right VPC is where we put our Databricks on AWS. Firstly, we started our linking scraper and indeed scraper every day at a scheduled time. So the Lambda functions scraped using some APIs like Bright Data or JobSpy to get the job information from these two websites and then store them into the S3 raw data lake. Then we use the step function to process the raw data to do the data validation and data duplications. After that, the data we use dbt and Databricks to build a data lake on top of S3. The two VPCs are connected using the net gateway. After that, we still also use dbt and Databricks to build the bronze, silver, and gold layers. After the layers are built, we extract the desired data from the silver layer. And the layer is the last layer in the silver and the red, which is ready for gold. We extract some data from it and do chunking and embedding, and then store the vectors in the QGround vector DB. And then we use Streamlit to do the retrieval, and as the visualization tool, also provide the communication interface with the user. For CI/CD and IAC part, we use Terraform to build IAC and GitHub Actions to build the AWS infrastructures. And next part will be introduced by Bruce.
Good afternoon, everyone. Our main raw resource are from two most large Australia online job searching website. They are LinkedIn and Indeed. For Indeed scraper, we use Bright Data API to simulate the cookie setting from Windows as a real person's browsing LinkedIn jobs. For Indeed scraper, we use a library called as JobSpy, which is an open source library from GitHub. The original library was more than 2 gigabytes. In case we want to map the environment to Lambda, we use ECR and Docker as a container to put the concentrated library from JobSpy around 400 megabytes to ensure the Lambda function can be run regularly. And we resumed the function for both of them to keep the data up in date. And the format of some simple data are down below.
Okay, yeah, thanks, Bruce. Okay, so next slide is about the brief S3 bucket structure and partitioning strategy. So here is the S3 bucket files structure. And all the files are partitioned by year, month, and day. And we have 4 key directories, which includes raw, bronze, and silver, and gold. So raw layer includes the raw JSON and Parquet files. So the raw data ingested from the previous 2 Lambda functions, as Bruce mentioned. And the bronze layer stores the delta tables for the raw data with data manipulations like standardizing the attributes name, etc. And then a silver layer captures the delta tables as well, but with further cleansing data and transformation, cleansing data and standardization logic. And the last part is the gold layer, which includes more complex business logic aggregation metrics. Next slide, please. So this slide focuses on the data formats and compressions we use in this project. So let's say for job information, it's stored in Parquet format, and actually for all the files, they are stored in Parquet format for better performance, better compression rate, as well as the faster queries performance. And the compression is snappy, and the rationale behind is really faster analytical queries and high compression rate. And then for job description text, it's the data format is JSON and compressed using gzip. So this one is applied or used more in the reg part of this project. So we can have simplified key value association for reg. Next slide, please. So now let's have a look at the schema axis. So if we take a closer look on the screenshot on the left-hand side, we designed these schemas, so which includes bronze, silver, and gold with associate files. So when we design the schema axis, we look at different data roles and business roles for this project. So on the right-hand side, we can see system admins have full access to all different schemas, and data engineer focus more on read and write access for these schemas. And the difference is that the data scientist can only have read-only access for the previous 2 schemas and focus more on wrangling the data in the gold schema layer. And then data analyst, again, doesn't have access to the bronze schema and have read-only access to silver and gold schema for reports development. And business users don't have access to the first 2 layers and only have read-only access to gold schema. And we also take data stewards into consideration because we want to focus on data governance and quality assurance, etc. So that's why we designed this role and access as well. So now my team member, George, is going to introduce detailed data flow and transformation logic details for the specific schema. So let's welcome George.
Hi everyone, this is George here. For data warehouse, we use the DataBricks on AWS. We have 3 layers, both silver and gold. For both layers, we have raw data from both LinkedIn and Indeed, and with the ingestions DTS and the resource file. For silver layer, we have raw data adding the metadata and the job description table and the unified table for both Indeed and LinkedIn merging. For gold layer, we have salary benchmark and market channel or aggregation metrics. All tables are incremented and stored into S3 bucket as a Parquet file. We'll talk about more technology in the next slide. For data warehouse designs, on the top, on the right picture, on the top there, we use the incremental. So we mainly use the updating, inserting, and we use the delta as the file format. So we still follow with ACID for time travel for the old versions, and partition by the file by time for the file. So that is easy for us to check in the S3 bucket. So which file from which date. And in the bottom of the demo picture, you see we have the filter with the latest data. So we only ingest with the latest data if we already have the data stored in the current storage. So please move to the next slides. We talk about more than layer. So for row layer, rows layer, so we ingest the data file and add in the data source file and the ingestion time. Please move to the next slide. We'll talk about a silver layer. For the silver layer, we standardize both the linking and indeed the data type, make sure they're same, so we can do the join step for the unify and the job descriptions table latest and align name. And we add the is active tag and enrich tag and job source flag for the future step in for next. And we also merge them into both into one table for both job description and the unified. So job description only include the job ID and the job descriptions, and unify including the job ID and the unified. When we decided, we use the job ID as the primary key, and we also remove all the duplicates, save the resources. So let's move to the gold layer, and the next slide, please. So gold layer will mainly on aggregation for the data type visualization and business user self-service. So we will pass to my colleague Bruce to discuss more on gold layer.
So hello again. Since we already got raw data and pre-processing from server layer to again metadata and job description, and also the unified table, we have some further and more complicated process for gold layer. We are focused on the suitable data to have commercial analysis and application. With some examples in salary benchmark, tendency of the higher marketing, and also the geography analysis for job marketing, job marketing analysis. We will have some conclusion in further. Let me explain the models first in next page. We have one main model to deliver all the data from silver layer to golden layer, which is styling and job posting. This is a priority model to run before for accessory model later on. In the next page, we have some example for the data process after the golden layer models. These four charts apply the data processed from a staging model and the second model. I know for, most of our audience are looking for some internship and full-time job. Sadly, internship just take a little bit amount over the entire job marketing, and full-time dominates over 84% of the market. Mid-senior level is the most popular seniority from the data science skill list. We can also see the New South Wales is nearly double the job quantity than Victoria in data science in data engineering field, and Queensland goes around another 1/3 quantity than Victoria has. For the salary part, we can see New South Wales has 5,000 more annual salary than Victoria. I think it, but the reason is still has least salary than other states is based on the is due to the diversity of the job seniority levels. Some possibly junior job would take more place and more quantity than other states. And next page I will use another two models, which are the first higher intelligence model and Australian job geography analysis model. We can hear from newspaper that New South Wales has like a more advanced jobs market than Victoria and other states, but it doesn't have like data support, quantity supports. Here I got some reference information might help you to recognize the tendency of which states has like more easier and more friendly to get a job. The opportunity number, the job number from New Wales are both nearly double, no matter regardless senior or entry level than Victoria's, and other states just take a little bit amount over the Australian marketing. And they are most concentrated in information technology and engineering field. The final page will display the final model from the student layer. Those two charts use the third skills model and the second job marketing heat map models. In left side, we can see in case that job is available to apply that are mostly concentrated in the 5 post days. That means it's better to apply the artist issue job as fast as possible you can. It gives you a fair opportunity to get in the job. In case it's full, it will be inactive and be dropped down from the job marketing. And this data source will be updated daily from the S3 bucket. In case you have data engineering skill, the most popular place is still software development. And the professional data and title for professional data engineer and data analyst just take 1/3 of the software development. So do not be tracked by the title of the job. Try to develop your skill, and you may find more about the job detail from software development, which might also require some data engineering skill, and you might explain this requirement. Let's move to the next stage.
Thank you, Bruce, for the very detailed introduction of our business intelligence system. And I will introduce our AI job description summarizer. And why we use this AI JD summarizer is because first is about the raw job description issues. It could be very verbose and cluttered, and some JD may not have very consistent formatting, and lots of them has many irrelevant details. Also, another issue is that the records scrapped from LinkedIn or Indeed, like this may lose some values for certain fields that we really need. For example, the seniority levels and the workplace type and some salaries. So these are missed in the original data. So what we do for this summarizer, firstly, we use large language model to summarize the job description in a very structured JSON format. Instead of just summarizing the job description, we use the LLM to summarize the job seniority level and workplace type in case to fill in the missed value of the raw data. Also, we summarize the domain classification here that can be used for our business intelligence analysis. For this, we build a knowledge base ourselves to make it as a more standardized classification. And then is our rec part. For our embedding, we use, as we talked before, we do the chunking for the summarized job description as for each job summarized, for each job, the summarized job description will only cost like 400 to 500 tokens. So it's perfect for one job to fit in one chunk. And it also ensures us it will not match other jobs if we want to search one. And for one chunk, we have the job posting ID and URL as the metadata. The main part is the text, which contains the responsibilities, skills, and the simple overviews. And the other important part is the skills. And this is the vector embedding distribution that distracted from the quadrant. And you can see this most data points are clustered. For the embedding model, we use the embedding 3 more from OpenAI, and vector size is this. Also, the embedding data are the job posting ID, AMI summarize, and apply URL. And we also use Streamlit to build an interface to visualize the rec system and as an interface to communicate with the users. And this is a simple visualization, and I will show you the demo at the end of my presentations. And this is another part. It's a detailed view of the top 10 job recommendations. And that's part will be introduced by Josh, who will introduce the IC and CI/CD.
Hi, this is George here. So for this project, we use the Terraform IAC infrastructure code. We cover the Lambda creation, including net gateway, create and delete, linking the job ID, clean duplicated, and step functions. This is auto scaling. We can scale from the 0 to 1,000 of a request automatically based on the demand what we need and change the variable for work on demand. So for security size, we use the independent IAM role to manage the IAC auctions. And we store in the distinct independent folder for a single IAC, and variable file are the same for all the management. So CI/CD size, so our code all stored in the GitHub, so we use the Git option for this stage. So we'll change the story and the full CI/CD orientation are stored there. So for the connections, we use the OIDC to link the CI/CD performed by the IMSS in AWS. We use the content hashing to supervise any code change and any plan we execute the code for in CI/CD. So we use the SHA-256 to compare the code and put the latest change and the script into the S3. So come back to Rowan for the orchestration.
Thank you, George.
Yeah. So this is a demo. So this is the demo for our CI/CD. So in the middle side we can see the Terraform plans is already started with and deployed. So we have Terraform apply with delete and the clean created and the indeed and linking for the step ID all shows. So all are successful in these pictures. We'll pass to Rowan for the orchestration.
Thank you, Rowan. Sorry, thank you, George. And I will introduce our orchestration. For the orchestration, we use a multi-agent system, which use LangGraph as the framework and use OPIC for monitoring the traces of the LangGraph. And this figure shows the record of the OPIC monitoring. And you can see that we have successfully run a help data pipeline using this multi-agent system. And however, our multi-agent system is mostly deterministic. So for each node, we can treat it as an agent, but for most agents, we didn't put AI in each of these agents. This is a breakdown of our state graph for the multi-agent systems. As you can see, at first, the agent there are two agents who start scraping the in-date data and linking data, and then it will start all data are passed to the state machine to do the data duplication and validation. At the same time, which is parallelized executed, is to net create. This is used to create a net gateway and elastic IP between our two VPCs so that we can try our best to reduce the phase of net gateways. And then B2 is the cluster selection node. In here, we introduce AI inside. So it can based on the length of like how many records we scraped for one day to decide which cluster on Databricks we need to use. And then after the cluster is decided, the after nodes are all DPT modeling nodes. It will modeling the bronze first and do the silver layers and finally the gold layers. Before the silver layer, you can see there is a summarizer agent, which is the JD summarizer I mentioned before. And after the layer reached the jobs enriched agent, it will go two parts. The first one, the newly scraped data will be chunked and embedded to our vector store, and the other part will go through our golden layer and do finally business intelligence part. And that's our lecture part. I will show you the demo. And can you see that? And can you see this? Okay, thank you. And this is the records for the OPIC to monitor the tracing of LangGraph. And that's that. And then I will share the demo for our Streamlit. Sorry, wait a second. Can we see this now? Can everyone see the Streamlit UI?
Yes.
Okay, thank you. Thank you. This is our Streamlit UI. As you can see, first page is about the job matching part. The user firstly can upload the resume in different formats like the PDF, docs, or TXT, or the user can just pass his resume there. So I will show you how to do this. We pause it here and pause it to click the button. On the right side, the first part shows your technical skills. It is the skills that extracted from the user's resume. And then is the skills gap analysis. It analyzes the skills that a user need to match the job market. And the next part is the job recommendations part. We can see there are top 10 job recommendations for each subpage. We can see the similarity score and skill match here. The user can see the job descriptions, job IDs, and the job sources, which is the job URL. The user can click it to apply. And the user also can have a table view of all the data for the convenience. Also, they can just download them as CSV or JSON. The other page is the resume chat part, which that here the user can chat with the AI about the resume. For example, let's click how can I improve the resume, and wait 2 seconds, it will generate the answers. And it will tell the user how to improve the resume, and maybe can ask what skills should I learn next. Yeah, there's the result. For our future plan, we want to develop a system that uses the AI to help the user to improve their resume, so that to increase the similarity scores here. Similarity scores so that the user's resume may be more matching to the original job JD, so that there will have more opportunities for the users to get the jobs. And that's all. Thank you.